Day 740 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1674, minimum moves to make array complementary, sorry. Difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums of even length n and an integer limit. In one move, you can replace any integer from nums with another integer between 1 and limit inclusive. The array nums is complementary if all indices I, zero index nums of I plus nums of n minus 1 minus I equal the same number. For example, the array 1, 2, 3, 4 is complementary because for all indices I, nums of I plus nums of n minus 1 minus I equal 5. Return the minimum number of moves required to make nums complementary. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input nums equals an array of integers 1, 2, 4, 3. Our limit is 4. The output is 1. So let's go through this explanation so we can see how we got this output from this input, right? Boom. So first thing I'm going to do, I'm going to copy and paste this over here so we can see what's going on. So we put input, boom. So first thing, in one move, we can change nums to 1, 2, 2, 3. The underlined elements are changed. So remember, it says up here that we can replace any integer nums with another integer between 1 and limit. So in this case, 1 is 4. So we are going to change this 4 to a 2. We're going to use one of our moves to replace 4, and we're going to replace it with the number 2. Boom. So after we do that, let's copy and paste this over here. Or actually, we could just do it here, right? Boom. So that's after change. So boom, we changed it. Input after change. Boom. Well, all right, let's just do it like this. Hold on. Boom. That's input after change. And then we could just put input before change, right? Boom. Sorry, y'all. Boom. So after the change, this is what we're left with. This is what we're looking at when we're trying to make it complementary. Boom. So let's go through it. So when I is equal to 0, right? Boom. So when I equals 0, nums of I is equal to 1. Boom. Then nums of 3, we're looking right here. So we're going to do plus nums of 3 because nums of 3 would be n minus 1 is going to be 3. Then minus I, which is equal to 0, we're still on 3, right? Because I is 0, so we're still on 3. So nums of 0 plus nums of 3 is equal to 4. So that's how we got this 4. Boom. I guess we don't really need the, or I guess just when we're going through it. Boom. So now we're at I equals 1. So nums of 1, we're looking at this array. Nums of 1 is equal to 2, right? Boom. So 2 nums of 1 plus nums of 2. So now we're at index 1. N minus 1 minus I, or excuse me, n minus 1 would be 3. I is equal to 1. So 3 minus 1, or excuse me, index 3 minus 1 will land right here on this 2. Boom. So 2 plus 2 is going to equal 4. Boom. Then we're going to do nums of 2. So now we're right here at nums of 2. Once again, n minus 1 would be 3. Minus 2 will be 1, 2. We're going to land on this 2 this time, and then 2 plus 2 is equal to 4. Boom. Then once again, we're at nums. We're starting at, well, that was I equals 2. Sorry, but now we're on I equals 3. Boom. So when I equals 3, we're right here. And then n minus 1 will be around this 3, but then minus I, since we're on 3, will be minus 3. So let's go 1, 2, 3. Then we land on this 1. 3 plus 1 equals 4. In the end, this is our complementary array. We were able to do that in one move when we turn this 4 into this 2. Boom. And since we could do that in one move, the output is 1. Now, just in case that didn't make sense, y'all, let's take a look at example 2. So, and one more thing to point out, all we're doing is we are just adding the outer layers versus the inner layers, right? So with this array, 1 plus 1, the outer layer would be 1 plus 3, that equals 4. The inner layer would be 2 plus 2, that equals 4. And then we do it backwards. The outer layer, 3 plus 1 equals 4. The inner layer, backwards, 2 plus 2 equals 4. And those are where all these 4s came from, right? So that's really all we're doing. But let's take a look at example 2, just in case that didn't make sense. So let me go ahead and copy and paste this again over here. This is before change. Boom. Then after the change right here. Boom. We set this to 0. Boom. It says in 2. So in example 2, our input nums equals an array of integers 1, 2, 2, 1. The limit is 2. The output is 2, right? It says in 2 moves, you can change nums to 2, 2, 2, 2. You cannot change any number to 3 since 3 is above the limit. Boom. So once every number is the same, then we already know once we add them all together, no matter how we add these numbers, that it'll be complementary because all of the numbers are same. So once again, this 2 plus this 2 is 4. These 2's plus each other is 4. This 2 plus this 2 is 4. This 2 plus this 2 is 2 is 4. So we know it's complementary because all the numbers are the same. And in total, we were able to do that in 2 moves. So that's why the output is 2. So now in example 3, we have our input nums equals an array of integers 1, 2, 1, 2. The limit is 2. This time the output is 0. It's nums is already complementary. So in this example, nums is already complementary, so we don't need to change anything or make any moves, so the output is still 0. As you can see, 1 plus 2 is going to be 3. 2 plus 1 is 3. 2 plus 1 this way is 3, and 1 plus 2 this way is 3, which makes it complementary. Boom. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution, as y'all know, is not going to be that difficult at all. So let's get into it. Now, first thing we're going to do is we're going to create a difference array, which will be used to track how many moves are needed for every possible target sum from 2 to 2 times limit. So we're going to just declare a variable called delta. We're going to say colon. It's going to be a dictionary of integers. Key is an integer. Value is an integer. Oh, sorry. It's going to be an array of integers, not dictionary of integers. And we're going to initialize it with an array. Open up the parentheses. Repeating colon 0 count colon 2 times limit plus 2. Boom. Then we're going to come underneath this, and we're going to say let n equal nums.count. Boom. Now we're going to iterate through the mirrored pairs in the array. So we're going to say for I in 0 less than n divided by 2. We're going to open up the brackets, and we're going to pair values from opposite ends. Because remember, all we're doing is we're just doing this plus this and this plus this just inside the layer, right? Just layer for layer. So we're going to say let A equal nums square bracket I, and we'll come underneath this and we'll say let B equals nums square bracket n minus 1 minus I. Boom. Now by default, we're going to assume every pair needs 2 moves. So we're just going to come underneath this, and we're going to say delta square bracket 2. We'll set that, or we'll say plus equals 2. Boom. Now if the target sum is between the minimum of A and B plus 1 and the maximum of A, B plus limit, then only one move is needed. So we'll come underneath this and we'll say delta square bracket min, open up the parentheses, A comma B, come outside those parentheses, we're going to say plus 1, come outside of that, and we're going to say minus equals 1. Boom. Then if the target sum equals exactly A plus B, then 0 moves are needed. So we'll come underneath this and we'll say delta square bracket A plus B, come outside of that and we'll say minus equals 1. Boom. Then after passing A plus B, move can count increases again. So we'll come underneath this and we'll say delta square bracket A plus B plus 1, come outside of that and say plus equals 1. Boom. Now after max AB plus limit, we go back to needing 2 moves. So we'll come underneath this and we'll say delta square bracket max, open up the parentheses A, comma B, come outside of that, we'll say plus limit plus 1, come outside of that, we'll say plus equals 1. Boom. Now we're going to store the minimum moves found by coming underneath this, and we're going to say declare a variable called res and set that equal to 2 times n. Boom. Then we're going to get the running prefix sum of the difference array by declaring a variable called cur, set that equal to 0. Now we're going to check every possible target sum by saying for I n 2 dot 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 2 times limit, we're going to open up the bracket and we're going to apply changes from the difference array. So we're going to say cur plus equals delta square bracket I. Boom. Sorry, y'all. Boom. Come underneath that. We're going to keep track of the minimum moves required by saying res equals min, open up the parentheses, res, comma, cur. Then we need to return the minimum number of moves needed by coming down here, and we could just say return res, y'all. Boom, that should be all she wrote. Let's give it a run. Make sure it runs properly. Okay, let's see. Oh, for I, it should be IN. So let's run that again. Let's see, it's accepted, so let's go ahead and submit it and make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 4 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.